Hey guys, so now we're back. We're on the next page in your packet. So we're going to do really the same thing that we just did with vertex form, but we're going to do graphing in detail for standard form. So you're going to see I'm going to follow the exact same process where I'm going to find the vertex, then I'm going to find at least 2 more points so I can connect it. So the only difference in this form is that when we look at it, we can't see the vertex. Okay, so it's not where we can see all those transformations the way we can when we look at it in vertex form, which is why a lot of times we like that vertex form better. So here, the only difference now when I have to find the vertex is I use a little formula for it. So this you might remember from 137. Vertex form you didn't do in 137. So I'm going to put it up top and then we'll use it each time. So in order to find the vertex when it's in standard form, you first find the x-coordinate of the vertex. So I'm not sure if this textbook uses a subscript of v, but that's how I kind of show it's not like an x-intercept. It's the x-coordinate of my vertex. You can find it by opposite of b over 2a. Okay, so all I need to know is those b and a. Let me just make that a little bit neater since we're going to use that all the time. I need to know B and A, and I can find, oh, sheesh, there we go, that's the best I can do. I can find the X part of my vertex, okay? To find the Y part of my vertex, well, if I know one part of my ordered pair, then I just plug in the function, so I find f of that negative b over 2a, just meaning, once I find the x coordinate, then I just plug into my function to find the rest of it. Okay, so let's try it. So in this case right here, for m of x equals 1/2 x squared minus 2x, a is 1/2, b is negative 2, c is 0 in this case. Not that we're using it in that formula, but so the first thing we're going to do is we're going to find our vertex just like the same order as the stuff that we did the last time. Okay, so find our vertex. So that we're going to find our x part of our vertex first, using this opposite of b over 2a. Okay, so I'm trying to straighten that up a little bit, sorry. Okay, so opposite of b in this case would be 2 over 2 times a, so 2 times 1/2. Alright, so this is really 1/2 of 2 is 1, so we have 2 over 1, so we have a 2. So we know, I'm going to put it over here on the side, our vertex is 2 comma something. Okay, so I need to find the rest of that ordered pair, so the y part of my vertex I find by just plugging in, by finding m of 2. Okay, so let's do that. So I have 1/2 2 squared minus 2 times 2. Tons of 2's in there. So 2 squared, so this part gets me a 4. 1/2 of that gets me a 2. So I really have 2 minus 4, so I have a negative 2. So there is the rest of my vertex. Okay, so let's plot that. So we have 2, negative 2. So there's my vertex right there. Okay, my line of symmetry is right down here. So my axis of symmetry is the line. It's not just 2, it's the whole line. X equals 2 is my line of symmetry. Okay, so I know when I finish this that this graph should be opening up and it should be a little bit wider because of that 1/2. So that A still controls the same thing as A controlled before. It's just that we don't have H and K in here. So we need to now find at least one more point, and we could always do a mirror image. So let's find, again, the y-intercept. So let's find m of 0. Let's see what's happening there. So I get 1/2 0 squared. So this one doesn't have any constant at the end, so I actually get out a 0. So this one goes through the origin. Okay, so if I do a mirror image of that one, so 2 away from my line of symmetry, my function's at 0. So 2 away, the other spot should also be at 0. So let's double check. So that would be a x value of 4. So let's just see what happens when I do m of 4, just to make sure. This will kind of give us justification, or give us a confirmation really, that our vertex is right, because these will be coming out to be mirror images. So if we have 1/2 4 squared minus 2 times 4, we get a 16 from the square, the 4 squared. 1/2 of that is 8 minus 8 equals 0. So that makes perfect sense. 4, 0 is another point on there. So if I connect it, it's hard to tell, you know, from here. Whoops. It is actually wider than the original. I mean, I'm just making it worse. Hold on. It is actually wider than that original one. It's not too wide. All right, that might be the best I'm going to get done there. Okay, so there's our graph. It opened up just like we knew it should. And we've got a detailed graph with at least 3 points on it, the vertex being one of them. So let's try it one more time. Let's do another one down here. Okay, what you might want to do is you might want to stop the video right now and try it on your own, and then start it back up and make sure we have the same graph if you want to use it as a practice problem. Either way, I just want you to have this all filled out because you're going to show me it on Tuesday. All right, so let's start with our vertex. All right, so we're going to start with our x part of our vertex as opposite of b over 2a. So this would be opposite of 2 over 2 times negative 1. So we have negative 2 over negative 2, so we have 1. So we know our vertex is 1 comma something. So the y part of the vertex, I'm just going to plug in that 1. Okay, make sure you realize that that negative is not included in the square. Okay, otherwise you're going to get a different value. Okay, so 1 squared is 1. Then I negate it. So I have a negative 1 plus 2 plus 1. So I end up getting out a 2. Okay, so my vertex is 1, 2. So my line of symmetry is down here. My axis of symmetry is the line x equals 1. Okay, so there's my start. When I finish this graph, because a is negative 1, it should be opening down, and it shouldn't really be wide or narrow. So let's find some points and see if that holds true. Okay, so let's find our y-intercept. That's the easiest thing to do. So h of 0, and you're going to see everything is going to drop out except that c, except that 1. So we end up getting a 1 there. So we've got the ordered pair 0, 1 we can plot. So 0, 1. You can already see that it's going to be pointing down. Okay, I always like to label the vertex because I could connect these two different ways, you know, making the blue one be the lowest and then opening up, but really the purple is the vertex, so that is the highest point. So just make sure you label it with a V so you can see which way to connect them. So the mirror image of that blue point here, I'm going to do in a black point. Okay, but then I'm just going to make sure so that would be, so the vertex is at 1, 2. So 1 away from the vertex on the left is my 0, 1 point. So the other one, let's find h of 2 and make sure those are truly mirror images. So if I do negative 2 squared plus 2 times 2 plus 1. So we end up getting a 4 here, but a negative 4 plus 4 plus 1, we end up getting a 1 out. So again, that's another pair. When we plugged in a 2, we got out a 1. So that makes perfect sense with what we did as our mirror image. So if I connect it now, it's opening down. Just like we thought. Okay, we knew at the beginning, we had an idea of what it should look like. We just needed to get some exact points so that we could have a detailed graph instead of a sketch. So everything in all my vertex, my axis of symmetry, my extra points, all kind of meshes well with the equation and what A is and what it should look like. And that should happen with every graph. Okay, so there we've got those two forms. We know how to graph by hand. And then there's going to be one more video that you're going to watch for the next page of your handout. Okay?